Development of STEAM learning activity sets using the research-based learning RBL process in teaching the subject of energy, resources, and environment. Mrs. Jerawan Chaikwan. 1. Problem statement. The course, Energy, Resources, and Environment, aims to develop learners' understanding of efficient energy use, resource conservation, and environmental impacts, key components of sustainable development within vocational education. Students in vocational institutions are expected to possess knowledge, skills, and attitudes that enable them to analyze and solve energy and environmental problems in real workplace settings. However, from the current teaching and learning practices, several issues have been identified. 1. Students demonstrate limited in-depth understanding of energy and environmental concepts, largely due to lecture-based instructional approaches. 2. There is insufficient integration of real-world contexts, resulting in weak analytical thinking and scientific problem-solving skills. Learning activities that encourage inquiry, experimentation, creativity, and hands-on product development are lacking, reducing learner motivation. The application of the STEAM approach, which emphasizes design thinking, creativity, and systematic problem-solving, is not yet evident in classroom practices. Research-based learning, RBL, which requires students to generate research questions, collect information, design and conduct investigations, and present findings, has not been implemented consistently in this course. Given these challenges, the researcher identified the need to develop a STEAM-based learning activity package integrating RBL processes to enhance students' understanding of energy and environmental concepts, promote systematic and creative problem-solving, and build their capacity to design products or innovations addressing environmental issues in vocational contexts. 2. Research methodology. This study employed a research and development methodology consisting of the following steps. Step 1. Needs assessment. Review of relevant curricula and professional competency standards. Interviews and surveys with teachers and students to identify learning problems and needs. Content analysis of the course to determine appropriate activity themes aligned with STEAM and RBL. Step 2. Design of the learning activity package. Learning activities were designed based on the STEAM framework: science, technology, engineering, arts, and mathematics. RBL processes were embedded into each activity, covering 1. Problem or question formulation, 2. Information searching, 3. Design and experimentation, 4. Product or innovation development, 5. Conclusion and presentation of findings. Development of teacher manuals, student worksheets, competency assessment tools, and rubrics. Step 3. Expert validation. Experts in STEAM education, RBL methodology, and energy environment instruction evaluated the content accuracy, appropriateness, and feasibility of the activity package. Item objective congruence values were analyzed and revisions were made accordingly. Step 4. Tryout and implementation. Tryout 1, small group, to inspect clarity, difficulty level, and time allocation. Tryout 2, large group, implementation in an actual classroom setting. Step 5, evaluation. Evaluation focused on 4 aspects. 1. Learning achievement, pre-test and post-test. 2. Problem-solving and engineering design skills. 3. Ability to conduct RBL-based mini-research. 4. Student satisfaction with the learning activities. Data analysis included mean, standard deviation, t-test for dependent samples, and qualitative content analysis. 3. Research results. 1. Quality of the learning activity package. Expert evaluations indicated that the activity package achieved high to very high levels of quality in terms of content accuracy, alignment with the STEAM framework, coherence of the RBL process, and overall feasibility for classroom implementation. 2. Learning achievement. Students' post-test scores were significantly higher than their pre-test scores, indicating that the activity package effectively enhanced their understanding of energy, resources, and environmental concepts. 3. Problem-solving and design thinking skills. Students demonstrated improved abilities in analyzing problems, planning and designing solutions, conducting experiments, and refining their prototype products. Their STEAM-based project assessments reflected creative thinking and systematic problem-solving. 4. RBL competency development. Learners were able to formulate research questions, gather relevant information, design investigations, and present their findings in a more structured and scientific manner. Their ability to provide scientific reasoning also showed clear improvement. 5. Student satisfaction. Students expressed high levels of satisfaction, particularly regarding the engaging nature of the activities, hands-on experience, product creation, and collaborative group work. Conclusion. The STEAM-based learning activity package integrating RBL processes proved to be effective in enhancing students' knowledge, creative and systematic problem-solving skills, and research competencies in the area of energy, resources, and environment. The results suggest that such integrated instructional approaches can significantly improve learning outcomes and student engagement within vocational education. That's all for this presentation. Thank you.